Hey everybody, we're going to talk today about how to calculate acceleration. Yesterday, you should have learned a little bit about acceleration, what it is, the definition, how it looks in the real world. And today we're going to learn how to calculate acceleration. So let's look at our worksheet for today. This is acceleration practice problems set 1. So at the top, it has our formula: acceleration equals final velocity minus initial velocity divided by time. So over here for our math triangle, in the top is going to be the final velocity. We represent that by VF minus the initial velocity, which is VI. We can have acceleration and then time in the bottom. Okay, so let's look at this. If we're going to solve for acceleration, we're going to do AF minus VI, and we want to do that first before we divide it by the time. Okay, so we need to make sure that we are subtracting first and then multiplying to make sure that it works right. If we're going to solve for time, it's going to be basically the same thing. You're going to subtract the velocities and then divide it by the acceleration. Okay, if we're trying to solve for either VF or VI, we're going to multiply acceleration times time to get the VF minus the VI. Okay, if we're solving for an individual VF or an individual VI, it'll be a little bit more complicated, and we'll have to look at that at another time in another video. Okay, so let's look at what these individual pieces mean. Okay, so remember, acceleration is a change in velocity, so speeding up, slowing down, or changing directions. So the variable that represents acceleration is A. The units for acceleration can be meters per second, or we can write it meters per second squared. Okay, it could be kilometers per hour, also written kilometers per hour squared. Or we sometimes see miles per hour since we are in America. And again, the time on that would just be squared. Okay, the final velocity, final means the end. So how fast is it going at the end? We represent this by a big V and a little F for final. Okay, and again, this is just velocity, so it's going to be meters per second, kilometers per hour, or miles per hour. The initial velocity, initial means the start or the beginning velocity. So how fast is it going at the beginning of the word problem? This is represented by the VI. And again, it's the exact same as the final: meters per second, kilometers per hour, miles per hour. Okay, and then time is still going to be represented by a T in minutes, seconds, or hours. Okay, so remember that time in metric system or our standard American system is all the same. Ones that are different here is velocity and acceleration. Remember that meters per second or kilometers is going to be metric system. Miles per hour is our American system. Okay, so we want to focus mainly on the metric system for most of the problems that we were working with in science. Okay, so the first part of this is really just a review over the notes that we did yesterday. So let's take a look at part 1. Part 1 is just some concept questions to make sure you understand what exactly we're talking about when we're talking about acceleration. So the first thing is, what is acceleration? Acceleration is a change in velocity. So remember that velocity is based off of a direction. So if we have a direction change, we also have acceleration. Okay, positive acceleration is speeding up. and negative acceleration is slowing down. The three different ways that we can cause acceleration is to speed up, slow down, or change direction. So speed up, slow down, or change direction. Number 5 says, what is the acceleration of a car that travels in a straight line at a constant speed? So this is a trick question. If it's a straight line, it is not changing direction. If it's at a constant speed, it's not speeding up and it's not slowing down. So the acceleration for this would be 0. And that's either going to be in meters per second or it could be kilometers per hour. And number 6, describe a situation in which you can accelerate even though your speed does not change. So an example of this would be if you are turning a corner, so going around a corner. Okay, so anytime you change your direction, even if you do not change your speed, you actually have acceleration. Okay, so you can make up any story you'd like to go with number 6 for that answer. Okay, let's look at our example here. It says a spaceship accelerated from 12 meters per second to 44 meters per second in 3 seconds. What was the average acceleration? So the trickiest part of these problems is figuring out which is the final velocity and which is the initial velocity. Because if you get these backwards, you're going to get the same number, but the positive or the negative value is going to be different, which means you're either going to be accelerating or you're going to be decelerating, which makes a big difference for our answer. Okay, so whatever the starting speed is, that is the initial velocity. And whatever the ending speed is, that is the final velocity. So for this problem, 12 is for the initial velocity and 44 is for the final velocity. The time here is 3 seconds. So that is the information given in our word problem. So we're going to take that, look at our formula. We're wanting to know what is the acceleration. So we're using acceleration equals final velocity minus initial velocity, all divided by time. Okay, so that's 44 minus 12 divided by 3. So when we do this, we want to do it in 2 steps. We want to subtract the top first before we divide. So if I subtract 44 minus 12, that gives me 32. Now I can divide it by 3. Remember, whatever is in the top is going to go in your calculator first, just to make sure you are dividing this correctly. Okay, so 32 divided by 3 is going to give me a positive 10.6 meters per second, and I can write it like this, or you can write it meter per second squared. So the reason we have 2 times here is because we have meters per second here, and we're dividing it by another second. So that's why we have 2 S's, 2 seconds, which is the same as saying that it's squared. Okay? All right, let's do one more example problem together. So let's look at example number 2. It says an electric powered bike accelerates from 6.5 meters per second to 10 meters per second in 4 seconds. What is the bike's average acceleration? So remember that wherever we're starting is the initial velocity, and whatever speed it's ending at is the final velocity. Remember, that is the most tricky part of these equations. Okay, so we're going to put the VF as 10, the VI as 6.5, and the time as 4 seconds. If you write the units in your givens, it's going to make the rest of this a lot easier, so make sure you're writing those units down. Okay, so for this one, we're looking for acceleration A, so we're going to use the same formula, VF minus VI over T. So when we plug this in and show our work, it's going to be 10 minus 6.5 divided by 4. So remember, we have to do the subtraction first. So 10 minus 6.5 gives you 3.5 divided by 4. So when we divide that, we get 0.88 meters per second, because I'm looking here to get my units. Or I can simplify it by just saying meters per second squared. All right, I hope that's helpful to you. Go ahead and try the rest of the worksheet, and if you have questions, let us know. Have a great day.